Good afternoon, everybody. My name is Gordon. I'm the Sales and Technical Support Manager from PCTEL. So today's topic, we'll talk about the wireless test and measurement for IoT. Okay, Internet of Things. They're being so widely deployed for the IoT or being evaluated right now, and there are so many connection technologies being identified so far. As a count of 39 different connection technologies. And some of them are based on satellite, 5G, some is being defined by the 3GPP or the IEEE, and also the Ethernet as well. And for PCTEL, our first focus, besides the LTE Cat-M, we're on the MPIOT side. As for the market updates, you can see that for the MPIOT in US is being chosen to deploy next year in 2018, while in Europe it's being deployed by Vodafone and also Dutch Telecom. In APAC, it's being evaluated or put under trial by different countries, for example in Japan, Korea, Australia, also Malaysia and China as well. And it will be deployed in Japan and Korea this year and next year. As for the LTE Cat-M, it's being deployed already by the local operator, and in APAC, it's also being evaluated or under trial by different countries, operators right now. For the LoRa, Sigfox, or some other technologies, it's also being evaluated by different countries, so they really haven't made up their decision yet. So you can see that for MPIOT, Cat-M, and LoRa is being evaluated by most of the APAC countries right now. So MPIOT, it's a good alternative for low power system. It's competitive in the mid-tier asset tracking. For example, think about the bike sharing system that you need to know and understand whereabouts your bike. Some people may leave it somewhere else, and if you don't have a way to track it, you will not be able to retrieve the bicycle back. Also, it has a great budget for agricultural and industrial application. But however, it's too late for the utility meter market because it has been implemented for quite years ago. For the MPIOT itself, it can be deployed in different ways. Either it can be deployed with it as an in-band configuration that works inside the LTE, FD-LTE system, or in a glide band, meaning between the two LTE signals. You can actually put in an MPIOT channel in there, or it can be treated as a standalone deployment, meaning that, for example, like GSM is exactly like 200 kilohertz per channel. You can basically reserve a channel solely for MPIOT. Okay, so from PCTEL, we're providing the measurement on the MPIOT in two phases. The first phase will be more on the power measurement to receive and measure the total received power within the user designated time and frequency intervals. While it's capable to measure any configuration ranging from 200 kilohertz to 180 kilohertz, which is one resource block wide, or even down to 15 kilohertz, which is every channel spacing for the MPIOT. While at the below, you can see that this is a very typical configuration to measure the MPIOT legworks, while you can set the time period to be every 10 milliseconds. And within that 10 milliseconds, you can choose to measure with only as short as 50 microseconds every time. While for the resolution bandwidth, you can set to the channel bandwidth, the channel spacing, which is 15 kilohertz in that case. The point of doing that is you can use the MPIOT enhanced power scan function from the scanner to find out the power over a specific time period and see if there's any bursty signal or time-based interference that have signal present that might interfere with the MPIOT legwork. So it will also be able to visualize if there's any empty slot when you're going to turn on the MPIOT legwork and see if there's any interfering signal that have signal presence. In the case of using the GSM channel for the MPIOT signal, some of the time you have customer have assigned a traffic channel in there which is quite bursty, And you can also use the enhanced power scan function to identify the signal that will interfere with the MPIOT signal. As well as the WCDMA or LTE, you'll be able to use the same scan to identify if it will have any interference to it. Now with the scanner's MPIOT EPS function, it will help you to verify the coverage for the MPIOT system itself.